Welcome to all. This is Rohit Nayak, practicing civil engineer from India. So in this video, we are going to understand the drainage problem in a roadway junction. So this is the most common drainage problem in most of the underpasses in India. Okay, so we have the location. So that is the Pumpwell circle of Mangalore. So that is been in the news for some time and quite often, I'll say. So due to the flooding and blocking the roadway connectivity from these uh, NH66. Okay, so if I want to highlight about the location, so this is the map of India, and this part is southern part of India, and this Pumpwell circle, which lies in the Mangalore city of Karnataka state. Okay, so I'll initially I want to try to bring some pictures of some rain event which happened in past. Okay, so I have brought you the some videos of the fast rainfall event which has occurred there. Okay, so let me go into it. So I have some pictures and videos. So let's try with the start with some of the pictures. Okay, so this is the one picture I have. So this is a picture of this roadway junction which is undergone some flooding. So you can see some stagnation of water near this roadway junction, and you can see this one where my mouse cursors are moving. So it is actually the side channel which is already started overflowing. Okay, and some so I have brought this picture. So if you can see this picture which I downloaded from the internet during the picture recorded during the flood events near the Pumpwell circle. So if you can observe that flooding has took place in and around this underpass and the circle area. But when you observe the this connecting road, so this connecting road is having the very small amount of stagnation water, or almost to zero stagnation of water. Okay, on this road, connecting road. So this could be the case that this road is on grade. Okay, and this underpass is more likely a possible case of sag point. So this underpass is in the sag point. Okay, so what does it says is that this junction is possibly in is on the lowest elevation, or you can say we can say in the civil engineering term, it's in the sag point. Okay, so I have some other pictures. So this is a video which occurred, which I recorded in the media. So this is the from the flyover, so down the circle. Uh, so this is the video recorded. Okay, fast 2 years back. So the July 2023 event. So you can clearly see the flooding. But as you go here, as you move away from this road, the flood depth has been reduced, so that it says that the accumulation of water is taking place only around uh, this underpass area only. So, and I have some other pictures to show you. Let me open this picture. Oh, sorry, this video. So this is the another video. It is right below the underpass. So you can clearly see a depth of water which is around feet. So feet or more. So you can see this stagnation of water right below the underpass. Okay. Okay, fine. So let's back to our location. So let's understand the topography of the surrounding area, how it is, and how it affect our uh, how it affect the Pumpwell circle. So what the government authority has missed during the master plan of this roadway underpass project. Okay, so this is the Pumpwell circle location. Okay, so here if you can closely observe, so it's a highly developed land, so it's a highly urbanized area. So all these commercial, it's a mostly the commercial area. in and around this roadway junction. Okay, so and when I delineated the natural drainages which influencing this pump well circle, so I found it something interesting which I want to share it now. Okay, so if I want to tell you a small brief about the drainage system of natural drainage system of this pump well near the pump well circle. So whatever the rainfall comes from the upstream will go from north to south, and finally it is going to discharge through the channels into the Netravati river. So Netravati river is a major river which is passing on the Mangalore city. So this is a Netravati river, and after that from the Netravati river it is going to discharge into the Arabian Sea. Okay, so this is a natural drainage path of this drainage system near this Pumpwell circle. Okay, so here, so if you observe the drainage path, so whatever lines which are seeing on the blue color lines are all the natural drainage lines. So wherever the water comes at this location, all comes travel through uh, on this blue color drainage line. Okay, and I have traced what is the limit of the catchment. Catchment is the area within which the all the rainfall contributing the discharge of the flow or the rainwater. Okay, so I have brought you that I have traced that catchment. So you can see this purple color line is the area limit of that stream. Okay, so this is nothing but the catchment or purple color line which I have drawn. Okay, so if you can go with this purple color line, so if I check this area, how much is the area? So I have this measurement tool here. So it shows it's 3.50 square kilometer. So in terms of hectares, it is 350 hectares of the catchment area. So so whatever the rainfall comes within this 350 acres of this catchment area all comes and discharge to this Pumpwell circle. So that is the reason which is causing, that is the one of the reason which is causing the flooding. I mentioned it is one of the reason. Why? Because there's other reasons are there that I will tell you in next. Okay, so I have considered the profile of this, how the longitudinal profile and the how is the vertical profile of this roadway junction. So these are the two profiles I have. Okay, this is the profile 1 and profile 2. So this is the profile 1 which I am showing you now. So this is the profile. So okay, so this is the profile. So can you see here? So this is the lowest point of 35 meter I am getting around this roadway junction, and once again it is going up. So this is the whatever the water comes here, it all get stagnated here when I considered from east to west profile. And one more, I have the north to south line. So this one you can see this red color line from north to south. Okay, so north to south profile I have. Similarly, it's on the same side. Okay, so it is also showing the same thing, that the stagnation of the sag point is this junction itself is the sag point. So that is the reason why why we are getting the stagnation of water, and why this pump well is going facing this flooding issues over the period of time since its construction has been completed. Okay, so let's come to the second point. That's the major point of the mitigation of underpass drainage issues, because it is not only the case of Pumpwell circle, it is the cases of most of the underpass circle in even in Bangalore, in Mumbai, or any other regions. So it is facing these underpass drainage issues, and this is the always the case that these underpasses are going on the flooding. Okay, so let's do some brainstorming and understand what are the stormwater mitigation ideas we can propose to prevent the flooding of this Pumpwell circle. So first option, would be these initially the what it seems from the initial option would be the increase in the size of the road drain. Okay, I have picture of this road drain. So can you see here? So let me bring that picture to you. So this is actually a roadway channel. This is a roadway side drain picture. So it is very small, and this is picture taken during the dredging work of this channel. So it is almost 2 to 2.5 feet by 3 feet. So it is, if you observe this picture, so it can you can see that this road drain is very small. It is almost 2 to 2.5 to 3 feet deep, 2.5 wider and 3 feet deeper. Okay. So what we can do proposal would be, so I know the catchment area. I can, as a civil engineer, I can use the engineering thumb rules. Okay. So I know the catchment area. Let me show you. So this is the catchment area. It's around the uh, 3.5 square kilometers. Okay. So from the some engineering judgment, I can you apply that 3 for the 3.5 square kilometers. So I can receive up to the discharge of for a peak discharge rate of 20 to 25 qmax. No, without doing any analysis, I'm using the engineering thumb rule. Okay, for this 3.5 kilometer of the catchment area. Okay, it's a, I can say it is a partly urbanized, because on the upstream you can see it is more of a green area, and development is taken place only on the near this junction. So what I can do, so based on this one, I can re-widen the roadway side drain. So based on this 20 to 25 qmax of the peak discharge, that is the option one I have. Okay. And the option two would be proposing acquiring the some lands. So it's like kind of a difficult task in India, but if any government lands are available, so we can acquire. So you can see wherever the multiple streams or the streams are matching, sorry, streams are meeting at a point or the confluence point. So we can propose some draft some ponds, and we can connect to the next pond. Like this we can do. So if I wait, let me bring this in a paint. Okay, let me take a quick snapshot of this one. Okay. Yeah, I took a quick snapshot. uh Let me quickly. Okay. Let me use the paint to explain my strategy. So wherever the multiple overland drainage paths are merging, or the confluence point of this drainage path, so I can propose some ponds. Okay, so this is my first pond. So this is somewhere I can propose some pond. So if government land is available, it would be great. So because the land acquisition process is very difficult in India, as a practicing engineer, I can tell. So I can propose some pond here, so that whatever the water comes from this part, from this eastern part, can store here, and whatever surplus water is there, I can divert it to next point. Okay, so I can propose the next pond somewhere here. Okay, so and secondly, I can propose a further next point in it somewhere here on the further downstream of this one. Okay, and I will connect uh, all these ponds with the help of drainage channels. Okay, I use this drainage channel to connect it here. Okay, and connect it here, something like this I can do. Okay, that is the option 2. And the first option, as I mentioned earlier, is the uh, rewidening of the existing drainage system, considering the 20 to 25 qmac of the peak flow. that is I used the thumb rule. It's not an exact figure, but it's based on my engineering experience. So that this area is 3.5. Okay, and it's not that fully developed. I can say it's a semi-urban kind of a thing. Okay, it's a semi-urban kind of a catchment. Okay, these are the two possible solution I brought. So if you have other suggestion as a civil engineer, you just comment on my video. So that would be great. And so thank you for watching. So I can bring more videos for you in the stormwater case study. So with the what are the problems which is faced in India, especially for the from the storm drainage point of view. If you can tell me to do a case study example of any of the roadway project or the some engineering project, just let me know. So thank you for watching.